One more quick thing. I'm going to talk you through the R code for this week. So we're going to be using two packages here, the Mosaic package and the car package. So the Mosaic package is nice because it has a lot of the stuff that we normally use, like ggplot, already in it. And then the car package, we use that for adjusted sums of squares. So we're going to look at the home prices data again. I did want to make a couple of changes to it. So one is that I changed the name of the lakefront, not lakefront variable to location, just because it's kind of confusing if you have lake is the name of the variable, but lake is also one of the categories. So I just renamed it using this rename function. And then I also used a mutate function to add the location variable coded as an effect. So this is like an if-then statement. R calls it if-else. So if location equals lakefront, then 1. So we're assigning that to the number 1. And then otherwise, so in this case, houses not on the lakefront get a -1. So remember, if you were to just run this part, if you were just to put home prices through the pipe and do these changes, oh, sorry, I got to import home prices first. My bad. And I want my headings to show up. All right, so if we were just to run this part, just have home prices and send it through these pipes, then that would print the data set, but it wouldn't actually save it, right? We still have the original home prices over here in our global environment. It is kind of nice to print though, because you can see what it looks like. So the original name of the lake variable is gone. It's just replaced by location. And then you can see what this effect variable looks like, right? So for everyone with a lakefront, that's going to be a 1, not lakefront is going to be a -1. So we're going to call this home prices 2. So I'm just assigning it to that name. And now I can see that in my global environment along with the extra variable. Okay, so this is kind of building on what we did last time, but we could start with a simple regression model. Remember, the Mosaic plot includes this plot model function, which is a really nice, very fast way to get a scatter plot out. And summary gives us a lot of the stuff we need: intercept, slope, t-test, f-test, r-squared, all of that. Okay. Then we started with an additive model. So this is using size and location as predictors, but with no interaction. So notice when we added the new predictor, we just put a plus sign in here. And what I like about the plot model function is because this is an additive model with no interaction term, it gives us parallel lines when it makes the graph. There are other ways to do this, like in ggplot, but in my opinion, this is by far the easiest one. So when I plot model 2, it automatically gives me those parallel lines. And again, summary gives me the information that I need. So here for additive model effect coding, I called this model 2.5 because it's going to be essentially the same. It's going to give you all the same predictions, except I'm using a different version of the location variable. Okay, so if I run that and run the summary, I can see that I'm getting different coefficients, but my measures of fit are all the same. So that's what we would expect. And remember, to get those adjusted sums of squares, you've got to use the capital A ANOVA function. So this comes from the car package, and this gives you adjusted sums of squares. Okay. The last model that we did include an interaction. There's 2 ways to write this. You can write it as square foot asterisk location, and that's going to give you, like if I go ahead and do the summary of that, it'll give you all 3 terms: the size, the location, and the interaction term, just by writing it that way. You can also explicitly write it out, so you can do square footage plus location plus the interaction term and write all 3 separately. It's going to give you the same thing either way. And then when we do plot model for model 3, you can see now that the slopes are different, right? This model allows each to have its own slope. And I didn't include it here, but you really could if you wanted to. You could do like a model 3.5 if you wanted to show the interaction model with a effect coding. So I just copied and pasted this here. The only thing I'm going to change is change this to an asterisk. And you can see we're going to get different coefficients, but the same measures of fit. So pretty straightforward. There's another activity that has you go through this in Socrative, and it should be giving you feedback as you go. If you run into any trouble, just let me know.